All right, welcome back. Algebra 1, Section 4 today, guys. We are in Section 4, adding and subtracting rational expressions. Listen, I know that this chapter is not easy. I know that there's a lot of big concepts, polynomials. I know they haven't gone away for multiple chapters, but this one specific section here, this covers... it's like it covers everything. All right. And I know I've probably said that before because at that point, maybe it did cover everything, but it just builds and builds and builds. And section 4, it just doesn't seem to skimp on anything. All right. So section 4 covers everything it feels like we've done. Okay. So pay close attention. All right. And I know I've said that so many times, but it's because it matters. All right. You can't skip steps. You can't just skimp out on the work. You guys can't zone out. I know it. Some of us, we're not big fans of math. I get that. But you just can't disappear. All right. Stay focused. Stay with me. Don't go through these problems quickly. All right, take the time to work through each step and look at each step. Okay, there you go. There's my talk. All right. Now, remember how to add and subtract fractions. All right, this is what we're doing. We're adding and subtracting fractions, except we're adding and subtracting fractions that possess seemingly 4 different polynomials. Okay? So that's, of course, the big twist to all this. When you add and subtract fractions, you guys have to have common denominators. All right, you can't just add or subtract 2 fractions that have different denominators. That's always, okay, step 1, got to get common denominators, and then you can proceed. The same rule applies, except that these denominators are polynomial expressions. All right, so they're not just one number, or even for that matter, one variable. It's a whole expression. All right, so I'm going to zoom in on this example right here so that you can see what it looks like when denominators are already the same, but you can also see when they start to have polynomial expressions. So this is a real basic. This is a monomial. All right, monomial meaning there's one term here. Okay. We have common denominators, all right? Same denominator. We are adding, so that means we're finding the sum of 2 expressions. Both denominators are 3x. Great. So then we can proceed to immediately combine the numerators or simplify the numerators. So all you're looking at is a 5 plus 7. That's how you get 12. And if your denominator is already the same, then that denominator just transfers right into your answer of 3x. Except that we're not done because a lot of polynomial expressions can be simplified. All right, you have figured out the sum. That part's good. But now what you're doing is you're simplifying a polynomial expression, like through division or simplifying fractions. So this is what I mean by we're going to start to pull it all together into this one section. So 12 over 3 makes 4, but the x stays in the denominator. That doesn't move up. That stays right there. Okay? All right. Next one, we have a binomial, x minus 1. Both denominators are the same, so we could immediately look at the numerators. But here's what happens with subtraction. All right, subtraction problems. This minus sign has to be combined with every term to the right. That is why they are putting this in parentheses, so that you take that negative sign and combine it with x. So that's really going to say 3x minus x. 3x minus x is how they are getting 2x. A positive 5 and that negative really will now make a negative 5. That's how they're simplifying down into their answers. Okay, and then this can't go anywhere. All right, remember that when you have this minus sign right here and here, that combines, or actually that locks the expression together. That means I cannot just take that x and that x away. That is not allowed. It is a all, meaning the whole expression, or none of the expression. All right, now let's take a look over here at a couple example problems where we don't have common denominators. This is where it really separates itself. Okay, 8x squared and 12x to the third. They are not the same. I can't make 8 become 12. So I have to think, what is a common number that both 8 and 12 can become? They can both become 24. So if you were doing regular fractions, there's no variables, and you had 8 and 12, then your common denominator would be 24. So you would take the 8 and you'd multiply it by 3. That's great. You take the 12 and multiply it by 2. That's great. But we also have a variable. Notice we have x to the third power. Over here we have x to the second power. So that means that this x squared, we're missing an x. We need another x to be there. That's why we're going to multiply this side with that extra x. So the 8 times 3 will get me 24. The x times the x squared will get me x to the third. All right, again, 8 times 3 gets me 24. X squared times x gets me x to the third. I need both denominators to be identical. Okay? Now, this side with the 12 already had x to the third. I don't need to change that x. It's already the way it should be. But the 12 needs to be changed. I need this 12 to become 24. And that's why I'm going to multiply it by 2. And what you hopefully have already noticed, just like with regular fractions here, what you do to the denominator, you do to the numerator. So I'm multiplying the 9 by the 3x. 9 times 3 gets me 27. And that x right there is that x right there. And then 5 times 2, that gets me 10. Okay? And then once I get down to this common denominator where both are 24x to the power of 3, I don't need to really write it twice. You'll notice I'm only writing it once in my answer, and then just combine the numerators. 27x plus 10. Why can I not combine that? Why does that not create 37? It does not create 37 because 27 has an x. The 10 doesn't have anything there. All right? You have to remember like terms. Only combine like terms. 27 has an x. The 10 doesn't have anything. So it's just put them next to each other. 27x plus 10. That's simplified. All right? Now, what happens if we are extremely different? Look at this. A 3x and then x plus 2. They have nothing in common. I can't magically take 3x and then put a plus sign there and make it say something else. So if you are looking at expressions like this, 3x cannot become x plus something. You just multiply them together. There is no special common denominator. So I have to create one. I have to make a common denominator. 3x times x plus 2. That's why they're showing it both places right here. But I do want you to understand, you do not have to multiply these together. See, throughout the whole problem, they just show them next to each other because that is the common denominator. Okay? Now, you do still have to multiply the numerators. All right? So the 10 will be distributed in here to the x and the 2. All right? And then the 7 will be multiplied by the 3, and the x will be multiplied by the other x. That is how we're getting this full trinomial here. 7 times 3, but don't forget that negative. That negative right there makes that 7 a negative. So a negative 7 times 3 gives you a negative 21. Then 10 times x gives you 10x. 10 times 2 gives you 20. All right? So that's a full problem. I know it's already worked out, but I wanted to guide you through it. So let's go through some problems together. All right, this one right here. Let's find the difference, meaning subtraction. And we have common denominators already. So we already possess common denominators, which means my denominator in my answer, we already know what that's going to be. That's going to be 2x minus 1. Okay, they're already common. But this negative sign, I have to distribute to both of these guys in here, right? When you have a negative, you have to put it with both terms or all terms to the right. So that's going to make this 2 become a negative. It's going to make that 3 become a positive. Now what I have to do is 4x and a negative 2x. Again, that's 4x and a negative 2x. They are like terms because they both have x. And they will create 2x. 4 minus 2. All right, and then we have positive 1 and positive 3, creating a positive 4. All right, so 2x plus 4, all divided by 2x minus 1. Now, in looking at this right here, you may think, okay, I could take a 2 out of each of these, but it won't help my answer. So it's okay to leave this right there simplified as is. It does not help you to take the 2 out. You can't simplify it any further. So there you go. Number 1, finding the difference, already with common denominators. Now, number 2, what I wanted to do here, so clearly our denominators are different. We actually are looking at trinomials, but all I wanted you to do was find the least common denominator. Okay, so we're not going to work out the whole problem with this one. We're just going to say, what would the common denominator be? All right, so we're just focusing on the denominator with this problem. Let's take this, and we are going to factor it. Let's take this one. We're going to factor that. And let's see what they factor down to. All right, x squared plus 4x minus 5. All right, when they go plus minus, parentheses go plus minus. X squared breaks down into x and another x. 5 is just 1 and 5. And yes, 1 and 5 can create 4, but we have to get the right combo. And it's going to be a positive 5 with the negative 1. Okay, so that one's factored. That part's done. Let's factor the x squared plus 7x plus 10. Both are plus signs. X squared breaks down into x with another x. Factors of 10 that make 7, 5, and 2. All right, so here's what I see. I see that x plus 5 is already common to both denominators. However, the x minus 1 and the x plus 2 is not common to each side. So what we already have, we have one common piece, x plus 5, but we have two non-common pieces, x minus 1 and x plus 2. And you can't just make them become each other. So this is what your common denominator would ultimately be. You would have x plus 5, because both sides possess that. X plus 5, only written once because both sides already possess it. But you would then have to have x minus 1 and x plus 2. That would be your common denominator. You would have to have all three expressions in parentheses next to each other. Then the denominators would be the same. So this right here is actually what your common denominator would be. Now, we're not going to go any further and actually solve this one out. This is kind of like baby steps working our way into simplifying with sum and difference where the denominators are not the same. Okay, so the next two problems we're going to work all the way through. Okay. So let's do this one. Find the sum. We're working just with monomials, right? Because we just have a single term and another single term here. So we need to figure out, starting with the numbers, starting with the coefficients, 2 and 5. 2 can't become 5, but 2 and 5 can both become 10. All right, so 2 and 5 can both become 10. So off to the side, I'm going to write what I know my common denominator should be. All right, so we know we have a 10. That is what 2 and 5 can both become. Now let's look at the variables. I have x to the power of 4 and then just x. Now, what's nice with variables is if you have one that's noticeably bigger, like x to the 4, you can make x become x to the 4 if you just take x and multiply it by x to the 3rd, right? So if you take x and you multiply it by x to the 3rd, it will become x to the 4th. So I can make x become x to the 4th, meaning that right there, 10x to the 4th, this is ultimately what I want my common denominator to be for both fractions. Okay, so now I just have to set it up by multiplying each denominator by what will make it become 10x to the 4th. So let's set this up. I would need to multiply this side by a 5x to the 3rd. 5 times 2 is 10. X to the 3rd times x becomes x to the 4th. But what you do to the denominator, you must do to the numerator. So then I have to have a 5x to the 3rd up here. Now let's take a look at this side. I have x to the 4th already, and that's what I want there. So I don't have to multiply it by any variables. I just need to multiply this side by a 2. All right, because 5 and 2 will make 10. Now we already know that each of these denominators, when we multiply that out, they will become 10x to the 4th. That part is really nice because we've already worked that out at the beginning. So 10x to the 4th, we know is the denominator. Now we need to start working with the numerator. Okay, we got a plus sign right there, right there. Now 7 times 2 is going to make 14. And then we have 3 times 5, which will make 15. And then x to the 3rd has nothing to go with right here. So x to the 3rd just drops into the answer. And looking at this, we can't go any further. We can't simplify this any further. There is nothing that can be taken out, crossed out, or simplified. So this is it. All right. Last example problem. This one's got more steps to it. So stay with me because now we have to factor And this is a difference problem right here. That's going to be coming into play. All right, let's start by looking at our denominators, factoring them, and seeing what do we really have to deal with. Okay, so let's factor this, and then let's factor this, and let's get down to what are we actually focused on with our common denominators. Okay, so x squared plus 2x minus 8. That's a trinomial that can factor. Plus minus goes plus minus. X squared, both are x. Factors of 8 that can create a 2, 4, and 2. And we want that 2 to be positive. So a positive 4 and a negative 2. Now, let's take a look at our x squared minus 4. This is a perfect square binomial. All right, a perfect square binomial. X squared is perfect, 4 is perfect, and it's a minus sign. You guys know whenever I say perfect, that means it's a perfect root. Like you can take the square root of it. The square root of x squared is x. The square root of 4 is 2. And with that minus sign in the middle right there, that makes the signs in here go plus minus. Here's something they share. X minus 2, x minus 2. They both share that. So we know that that will be in our denominator. But what they don't share is an x plus 2. And then on this side, an x plus 4. Neither of them share that. So that means that we are actually going to have 3 sets of parentheses in our denominator to get this common denominator. So that common denominator, I'll move up a little bit here. That common denominator is going to be x minus 2. They both share it, right? Remember, x minus 2, x minus 2, and then x plus 2, x plus 4. So we have to have all three parts. Whatever they have in common, you don't write twice because they each already have it. They share that. So down here, let's write what that common denominator will be. X minus 2. They already each have it. They share that. But then x plus 2, x plus 4. So all this work right here was just to get the denominator. Now comes the work, all right, with this numerator. Okay, so here's what we have. For starters, we still have a negative sign that needs to be distributed to both parts with the x and with the 1. All right, and when that happens, that's going to create a negative x, and that's going to change that plus sign to now be a minus 1. Now what you have to do is ask, they both shared x minus 2, but what was this side lacking? It was lacking the x plus 4. So we have to multiply the numerator by x plus 4. That's what it was missing. I'm going to go ahead and put this in parentheses so that we can see the expression we're actually dealing with, a negative x minus 1 times x plus 4. Notice there's 2 binomials. You guys remember doing double distributive property? Because that's what we're doing again. Distribute, distribute, then distribute, distribute. Okay, now on this side here, this denominator was lacking the x plus 2. Notice you don't see any x plus 2's there. We have to move that x plus 2, and we're going to multiply this numerator by x plus 2. And again, double distributive property. Distribute that x to both parts. Distribute that 2 to both parts. When you do double distributive property, a binomial times another binomial, I'm going to put this in parentheses also, so they look similar. you're going to create a trinomial. So here is where slow and steady and precise pays off. All right. This right here, when you multiply it, you're going to have x times 2x, giving you 2x squared. Then you're going to have x times -1, giving you -x. Then 2 times 2x, giving you a positive 4x. Then, let's see. To get that. Okay, sorry. I was looking at my notes there. All right, then we have 2 times -1, getting us -2. And what you should see, let's take a pause, is we have common denominators right here. X, -x actually, -x, and positive 4x. They are common denominators that can be simplified. So let's do that. All right, we're going to simplify it. And that means that a -x and a positive 4x, it's really like 4 minus 1. Okay, so on your paper, don't erase. Okay, but just to save some space here, I'm going to show you that this really becomes a positive 3x, and then we still have that -2. Okay. All right, now we have to do the exact same thing on this side. Two binomials. -x times x. That makes a -x squared. -x times a positive 4 makes a -4x. All right, now a -1 times x makes a -x. Extend that out a little bit. Sorry, that doesn't match up. That's okay. And then a -1 and 4 make a -4. Okay. We have more common denominators. Sorry, we have more common terms, like terms right here. Like term -4x and -x. So -4x and -x, they are like terms in the same family. So when we simplify them, we get a -5x. All right, and we are almost done, but we have more like terms. All right, we have more like terms. I'm going to get some more space here. Let's bring this up a bit. Okay, so that way we can work underneath it with a little bit more space. All right. So let's write our common denominator one last time. X minus 2, x plus 2, x plus 4. Okay, so with that, all I did, just wrote that denominator down there. Okay, now look at the numerator. We have an x squared right there, and we have a -x squared right there. We have a positive 3x. We have a -5x. We have a -2 and a -4. So notice we have three groups of like terms that all need to be combined together. So the x squareds, when you combine them together, they just make x squared. 2 minus 1 minus 2x, that is 3x and -5x, making a -2x. and then minus 6. And that is -2, -4, -6. All right. That covers us. That is the answer right there. That is a big problem, about as hard as they get. But I wanted to show you one worked out to give you every step. All right. And let's go ahead and zoom out here. So that's example problems 3 and 4 worked out for you. Example problems 1 and 2. We can almost fit them all on the same page. Not quite. Okay. So example problems there, right there. All right. So as I said, this covers like almost everything. Okay. And I need to make sure that you guys are still with me. I know these videos are longer than you're used to, but it's just because I want to show you every step and give you every little detail so you take the time to do it so that I can help you even better in class. All right. Thank you guys. I will see you in the next one.